lecture we'll try to learn about sample and hold circuit. Let us see what is a sample and hold circuit. So sample and hold circuit, as its name tells that samples, this particular circuit will be sampling some input signal and holding on to its last sampled value until the input is sampled again. Means what? Whenever you give some input signal, that input signal will be sampled. It means it will be converted in terms of samples, small amount of input signals, and that whatever the data is there, that will be held in the output part until a new sample again comes, until a new input signal is given. So in this circuit we can see there we have used here N channel E MOSFET. What is E MOSFET here? What is E MOSFET? Excuse me.
Enhancement Mosfet.
Enhancement MOSFET. What is an enhancement MOSFET? Enhancement MOSFET is a MOSFET where initially that MOSFET will be in the off state. So in order to turn on the MOSFET, we are supposed to supply some input voltage, that is called as a gate voltage. Gate voltage has to be given over here. Whenever the gate voltage will be greater than the threshold voltage, the MOSFET will be turned on. Turning on means what? Whenever, see, that's why we have given some voltage here. This gate voltage is given. This gate voltage is called as a sample and hold control voltage. So this gate voltage is used to turn on this MOSFET, E MOSFET. Whenever this MOSFET is turned on, slowly depending upon the gate voltage, the channel has been formed. Whenever the channel is formed, we can pass this input signal through the MOSFET to this op amp. So this is this particular MOSFET. Can you tell what is the application of E MOSFET over here? Looking at what are the operation of E MOSFET I have told just now. What I told, if you give some gate voltage, depending upon the gate voltage, means the gate voltage has to be must be greater than the threshold voltage of this one. If it is greater than the threshold voltage this one, then only the channel is formed. Whenever the channel is formed, your input signal is been passing through the E MOSFET to the op amp. If the channel is not formed, the input signal will not be passed to the op amp. Can anyone tell me what is the application of E MOSFET over here? What is
As
the
a
application of?
on-off switch.
Kya?
As a on-off switch.
Good. This E MOSFET is acting as a switch. It is acting as a switch that is controlled by the sample and hold voltage, control voltage. Control voltage is nothing else but the voltage which we used to turn on this transistor or turn off this transistor. So now in this circuit you can also see there is a control voltage Vs is there, and again a capacitor C is there. Where is the capacitor C? This capacitor C is what? It is acting as a storage element. This capacitor C is acting as a storage element, and the analog signal input signal Vin is supplied, and that input signal has been sampled. The input signal is to be sampled, and where does it will be sampling? It will sample at the drain terminal. Why? Because you are applying the input signal to the drain of this MOSFET. Means your analog input signal to be sampled, which is to be sampled, is applied at the drain of the MOSFET, and the sample and hold voltage, is applied to the gate of this MOSFET. Whenever the sample and gate voltage is greater than the threshold voltage of this MOSFET, then what happens? The MOSFET is turned on. So now your sampled data, which are the data is to be sampled, is at the drain terminal. It's the drain terminal of the E MOSFET. Now let us see what happens here. Now during the positive cycle of the Vs, the E MOSFET conducts and acts as a closed switch. During the positive cycle of the Vs, this is a Vs which you are applying here. So during the positive cycle of the Vs, what is happening here? Your E MOSFET will be turned on. Whenever the E MOSFET is turned on, I can say it is a closed switch. It is acting as a closed switch. Now whenever it is closed switch, what happens? This allows the input voltage. What are the input voltages there? This allows the input voltage to charge the capacitor. If this MOSFET is turned on, the input voltage will be flowing through the MOSFET, and that helps the capacitor to charge up. Whenever the capacitor is charged up, we can say there is some kind of charge is stored in the capacitor. So or else I can put it in the other words. In other words, whenever the input voltage appears across the C, I can say in turn at the output it is been reflected. See, it means that whenever we are supplying some input voltage, that input voltage is traveling through the MOSFET and that is being stored in the capacitor. And this capacitor will, whatever the input voltage is here stored in the capacitor, that will be appeared at the output Vout. So now I can say whenever the input voltage, whenever this MOSFET is turned on, you are having some output voltage depending upon the charging of the capacitor due to the flowing of charge from the input voltage into this capacitor. So now let us go to the other part. When does this happen, charging of capacitor? Whenever your positive cycle of this one, positive cycle of this Vs, whenever the positive cycle of Vs happens, the charging of capacitor takes place. Now let us go to the other hand. What is the other hand? Whenever the Vs is 0, whenever the Vs is 0, whenever the Vs is 0 means what? The gate voltage which you apply to the MOSFET is almost 0. It is 0. Then whenever the gate voltage is 0, what happens to the MOSFET? The MOSFET is turned off. MOSFET is turned off means what? It is not conducting, it is not working. If it is not working means what? It is completely open circuit. There is no connection between these two parts, drain and source. Means the complete op-amp is got disconnected with the input signal. Your complete op-amp has got disconnected with the input signal. Whenever it is completely disconnected, then definitely what is there? There is no flow of charge into the capacitor. If there is no flow of charge into the capacitor, just like what you have seen in the previous case, there will be discharging of the capacitor takes place. The discharging of the capacitor will be taking place. The only discharging path for the capacitor is, therefore, the capacitor will be discharging through this ground terminal. So that is the only discharging path. Whenever this discharging happens, how does the discharging happens? Since this is connected to ground and all this are connected to ground, the discharging also should happen through this op-amp. So whenever this input signal is not connected over here, whatever the capacitor is earlier charged, that will be slowly discharging. The only discharging path will be between this op-amp and the ground. Between this op-amp and the ground, the discharging will be taking place. So however, we have got some input resistance of the op-amp, which is acting as a voltage follower, which is very high. So you can see here now, there is one input resistance over here. This input resistance is very high because of this one, and you can see what is happening to the op-amp. The op-amp is directly connected. The negative terminal of op-amp is directly connected to the output. I can say now this is acting as what? Voltage follower. That's why what I told you, whenever this is completely charged up, then it will produce that output at that value at the output. Why it is producing at value at the output? Because whatever the voltage across this capacitor is connected to the input of this op-amp. Your op-amp is in the voltage follower mode. Since your op-amp is in the voltage follower mode, whatever the input you supply at the input part of the terminal of the op-amp will be obtained at the output. So now that's why your output is at the your input is reflected at the output. Is it clear up to here?
Yes, sir.
So now let us see. You can see these are the TS is given, TH is given. So this is a sample period. In the sample period, what is happening? In the sample period, the charging of capacitor is taking place. In the hold period, what is happening? In the hold period, whatever the data is stored here, that will be held at the output. That is a hold operation is taking place. The hold operation means what now? The sampling happens where the MOSFET is on. Whenever the MOSFET is on, the sampling of this particular capacitor is happening. Whenever the MOSFET is off, what is happening? This particular, whatever the charge is there, it is reflected at the output. Why it is reflected at the output? Because your circuit is acting as a voltage follower. So this is called as, since my data stored in the capacitor is held at the output, I can say this is the hold period. So there are two kinds of operation in the what is the sample and hold circuit. One is the sample periods and other one is the hold periods. In the sample periods, what happens? Your MOSFET is going to be turned on. Whenever the MOSFET is turned on, your capacitor is going to be charged up. That particular value of capacitor will be charged up with respect to the input voltage. Now what happens in the hold period? In the hold period, MOSFET is going to be turned off. Since my MOSFET is turned off here, the periods of this time period of this hold operation, that's the TH you can see here now. The time period of this hold operation TH of the output voltage or this Vs, sorry, not output voltage, it's a Vs, sample and hold control voltage Vs. During this one, what happens? The voltage across the capacitor is constant, and that's why we call whatever the capacitor value is held here, that is obtained at the output. So this is called as a sample and hold operation. So this is in sample and hold operation. One time the whatever the data which is to be sampled will be held in the on state of the MOSFET. In the off state of the MOSFET, what happens? We call that period as an hold operation, and during the hold operation, the whatever the voltage is stored in the capacitor is been held in this output part. Therefore, we can say the output of a op amp is usually processed and observed during the hold period. Therefore, your output will be always processing or observed during the hold period. It will hold the operation, it will observe the operation, it will observe the data which is stored in the capacitor. So that's why we call this kind of operations as a this kind of circuit as a sample and hold circuits. And one more thing, mostly for the high speed op amps, we are supposed to use the capacitor which is of a low leakage capacitor. Why? Because our entire operation of this sample and hold is working on the capacitor only. If capacitor is leaking the charge, what happens? I may not get the correct output here. The output will be an degraded output. It will be a degraded output. So in order to have a good capacitor, always this is one of the important objective. You are supposed to use a low charging. You are supposed to have a low leakage capacitor. The capacitor should be low leakage capacitor. The examples could be Teflon or polyethylene capacitors. We are supposed to use here Teflon capacitors or else polyethylene capacitors. Those are the low leakage capacitors. These low leakage capacitors are used what? In order to hold the capacitor or in order to hold the charge which is stored in the capacitor. Now let us see the applications. Where are this sample and hold circuits have been used? The sample and hold circuit is commonly used where? In the digital interfacing and communications. What kind of communications? We'll be using in the digital interfacing and communications like A to D converters. A to D converters means analog to digital converters, or it can also used in the pulse modulation systems. In the pulse modulations, just now we have seen frequency modulations and those kind of things. These are used for digital interfacing. It is used for analog to digital conversion. It is used for pulse modulation. These are the applications which are important objectives. Sample and hold operations are used for what? Used for digital interfacing, used for analog to digital conversions, is used for pulse modulation. And what kind of capacitor we should use here? We are supposed to use a low leakage capacitor. Wow. What are the examples of low leakage capacitor? The low leakage capacitors can be Teflon capacitor, Teflon, T-E-F-L-O-N, Teflon capacitors, or else it could be polyethylene capacitors. These are the low leakage capacitors. So this is how your circuit is operating with respect to your input voltage and with respect to your MOSFET on and off conditions. So in the sample and hold, there will be only two kinds of operations. One is a sampling of the data into the circuit and again holding the data. So sampling of the data happens whenever the MOSFET is on, and holding of the data across this output will be happening whenever the MOSFET is off. So this is called as a sample and hold circuit operation.